Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ijaz Syahmi bin Samsudin. My metric number is DD180062. And for today, we will present our open-ended experiment, which is a reversible steady flow for multistage compression with intercooler. So this presentation will consist of 7 subtopics, which is introduction, experimental theory, procedure, result, observation, discussion and conclusion. And each of the group member will present according to their task given before the experiment have been done. Let's begin.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hakim Afiq bin Muhammad Fazil. My metric number is AD170304. For the introduction part of this report, an air compressor is a machine that raises the pressure of air in a confined space. A two-stage air compressor uses a two-cylinder system and is usually used for heavy-duty work. The air is used to produce energy and power for industrial, commercial and personal use. In the compressor, the first piston compresses the air and transfers it to the second storage tank where it is deposited for subsequent process. Some of the usage of two-stage air compressor can be seen at a gas station and manufacturing plants. It is also well known that a two-stage air compressor is more energy efficient than a single-stage air compressor, and it has a longer life.
Next is the additional theory. So, for the additional theory, I will explain about the single stage and the multi-stage compressor. So, what is the compressor? An air compressor is a device that changes power into potential energy that in compressed air. An air compressor forces more and more into a storage tank is the one of the several methods. When tank pressure reaches its highest limit, the air compressor shuts off. The compressed air is held in the tank until called use. There are a single and two-stage compressor, which is used in industrial. In a single stage, the air is compressed once and air is compressed twice for double the pressure for two-stage compressor. The number of times the air get compressed between the inlet valve and the tool nozzle is the main difference between single and two-stage compressor. Two-stage compressor are more efficient in pumping compared to a single-stage compressor. The two-stage compressor are always cool and efficient or high pressure because the air is cool between the stage. When more power is used, less heat will generate. A two-stage compressor is better than traditional electric power generate because it generates more power and they are safer than other power generation system. A two-stage air compressor is very efficient in most cases than other compressors because it can be used continuously for a long period of time depends on the desired period. So, for the next, let's see how a piston type air compressor works. If you are familiar with the piston in your car, then you can imagine how this compressor works. So for the first step is piston type air compressor works by using the piston to fill the tank with air. Second, valve and gasket around it seal the air to prevent it from escaping as the piston draws air from outside. For the third, after the cycle, more air is pumped into chamber to increase pressure. So for the fourth is with dual acting model, the piston are placed in an L formation. So for the L formation, a vertical cylinder is low pressure and the horizontal cylinder is high pressure. How air compressor works? So, for the next, how air compressor works. First step, the compressor system begins to look downwards into the cylinder that creates a partial vacuum in the atmospheric pressure that open the inlet valve. Second, the cylinder is filled with atmospheric pressure as the piston goes down. The piston begins to go upward again when the crankshaft complete careful revolution. Then the pressure generated inside the cylinder. Next, the increased pressure open the automatic outlet valve. And next, the outlet valve close again when the piston reach its maximum upper position. And for the last one, the cycle repeat itself and the pressure becomes higher and higher inside the storage tank.
Okay, so next I will explain to you about the experimental procedure, which is we need to know to fully understand and know how to do the experiment correctly. Okay, so we're moving on to step 1, which is turn on the water supply. Step 2, set the water flow rate to 100 liter per hour for both pipe. Step 3, turn on the compressor by turning the power key. Step 4, put on ear protection equipment. Step 5, attach the hose to pipe with a pressure of 2.5 bar. Step 6, lift the lever of the pipe. Step 7, adjust the pressure using the release valve. Step 8, set the selector number 1 to 1. Step 9, wait for 10 minutes before taking T0 and P0 reading. Step 10, set the selector number 1 to 2. Wait for 10 minutes before taking T1 and P1 reading. Step 12, set the selector number 1 to 3, 4 and 5 to take T2 and T3 reading in order. Wait for 10 minutes before taking T4 and P3 reading. Step 14, set the selector number 2 to 1, 2, 3, 4 and 5 to take T5, T6, T7, T8 and T9 reading in order. Number 15, bring down the lever to close the pipe. Number 16, repeat step 6 to 15 using pipe with pressure 4 bar and 7 bar. Number 7, turn the red button to turn off the compressor. That's all from me. Thank you.
Hi, my name is Muhammad Hafiz Albar bin Aisai and I will explain to you the observation that has been made throughout the experiment. So at the start of the experiment, we need to make sure that the reading of water circuit 1 and 2 both at 100 liter per hour. However, we observed that the reading was not stable and unsteady. Next, we set up the P4 reading to 2.5 bar, 4 bar and 7 bar. As we set up this reading, the reading of the water circuit flow rate seems start to be steady. And now we can fill the table. So we proceed to the table. So from the first table of the result, we observe that the temperature and the pressure will increase from the ambient air until second state of compression. After the final compression, the temperature and pressure will decrease. We observe that higher gauge pressure will produce higher reading of TO until T4 and PO until P3. And this is the second table of the result. Here we can observe that the temperature of T5 until T9, the airflow rate, the input power, and water circuit level for 1 and 2. We observe that the higher input power will use as the P4 is adjusted from 2.5 bar to 7 bar. By increasing the pressure of P4, the value of water circuit level for 1 and 2 and the airflow rate will decrease. Increase in gauge pressure P4 means that tank temperature T5 and air tank temperature will increase as well.
for the discussion of this experiment. The aim of this experiment was to demonstrate the application of the first law of thermodynamics. The first law states that the internal energy of the system will change if energy is added or taken from the system. This can be seen when the air goes through the compressor. Both the temperature and pressure of air increases after passing through the first and second state compression. For the process to be considered as adiabatic, no exchange of heat can happen between the system and the surrounding area. So the process has to be an isothermal process when the where the polytropic index n is equal to 1. Since the n that is calculated does not equal to 1, this process cannot be considered as an adiabatic process, and there is exchange of heat between the system and the surrounding area. By using the formula, temperature 2 over temperature 1 equals to pressure 2 over pressure 1 to the power of n minus 1 over n. The theoretical value at P2 can be calculated. The theoretical value and the experimental value at P2 has a small difference. This shows that the experiment follows the law of thermodynamics.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zarul Arif bin Muhammad Zakaria. My matric card number is AD170096. I'm from group 3B and I'm going to present about conclusion and recommendation for our experiment. As for conclusion, from the data in this experiment, we can conclude that two-stage compressor provides a higher efficiency of air compressing work compared to a single-stage compressor. Two-stage air compressor is applied when high output pressure is needed for higher efficiency and lower power input. Single-stage compressor cannot produce a very high output pressure. This is because there are mechanical limitations for the single-stage compressor. Next, for the adiabatic, we can be considered in this process because there is no exchange of heat between the system and the surrounding. Since it is polytropic index that can be calculated because they are not equal to 1, so this process can be considered as adiabatic. Moreover, the polytropic coefficient, which is pi, for all the pressure in this compressor are 0.557, 0.7764 and 0.8049, which it can be related to the efficiency that are almost perfect in this experiment. For the last one, in this experiment we can conclude that intercooler and aftercooler play an important role to increase the efficiency of the system by cooling the heat produced during the compression and to remove the moisture formed during the compression. As for recommendation, from this experiment, there are few things that we need to improve to get a better result. Firstly, we should close all unnecessary valves and make sure all the valves are working well. This is because if the valve is broken, it can affect the flow rate of the air. Next, the motor speed. The motor speed, which is RPM, must be adjusted and must be maintained in this experiment. The data we should record immediately to prevent any misreading while the experiment being conducted. Moreover, make sure there are no leakage of air due to prevent the pressure drop, and it may lead to lack of capacity, which may cause the data is not accurate. Besides, air filter could be well maintained regularly to prevent unwanted pressure obtained that can cause by the clogs or at the air filter. Also, we should regularly replace the air filter so that there will be not affect the capacity of air to the compressor. And the last one, we should use high capacity of coolant to help the motor efficiency decrease and the loss of energy heat to the surroundings. Thank you.